meter bridge அப்படிங்கிறது it's an application of windstone bridge. Okay, so meter bridge அப்படிங்கிறது பாத்தீங்க அப்படின்னா it's made up of wood and see the point A and C. A and C is connected with the magnet or constantine wire, constantine or magnet wire. A, C is connected with the constantine or magnet wire, and this point A is connected to the Lagrange cell, then Lagrange cell to the key, and key to the point C. And here you see that it has the two gap G1 and G2. G1 and G2 are the two gap. That gap G1 is connected with the unknown resistance P. So P is the unknown resistance, and Q is connected to the gap G2. So it's a known resistance Q. So Q is a known resistance. We can fix the value of resistance 10 ohm, 15 ohm, 20 ohm like that. So it's a known resistance. Is fixed in the gap G2. And the point P. So B2, the galvanometer G, then galvanometer to high resistance to jockey. Okay, so here that point AC is connected to the constantine or magnet wire. The length of the wire is 1 meter, so it's called a meter bridge. So using that, we can calculate the unknown resistance by using the known resistance. So you know that in windstone bridge, 4 resistance are there. P, Q, RS are the 4 resistance. In that equation, P by Q equal to R by S. If you know any 3 value, you can calculate the 4th value. So that is the rule of the to find the unknown resistance in windstone bridge. So that windstone bridge is the basic principle of the meter bridge. Here 2 resistance. One is the P and Q. So P is unknown resistance, Q is the known resistance. Another 2 resistance is the here that wire. So from A to C is a 1 meter wire. So this is a metal jockey. So the metal jockey மேல வச்சு நம்ம நகர்த்தணும் அப்படின்னா என்ன ஆகும் அப்படின்னா that galvanometer shows the zero deflection. That means that potential difference from A to J. So where you are placing the jockey, that point is taken as a J. From A to J and J to C. A to J, then J to C are the 4 parts. So P, Q, A, J and JC are the 4 resistance. Here that conductor, constant magnet, whatever it is, it has the resistance. So here that resistance is taken as AJ and JC are the another 2 resistance. So 4 resistance. நமக்கிட்ட இப்ப 4 resistance இருக்கு. One on the P, another one is the Q, another one is AJ and JC. So if you know any 3 value, you can calculate another 1 value. That is the windstone bridge rule. So using that, now we are going to see that how to calculate the unknown resistance, right? So it is a thick metal copper wire is placed on the wooden board மேல வச்சிருக்கோம். So that is the 2 gap G1 and G2. Center point is B. So uniform magnet wire is connected between A and C. That is 1 meter length wire. That is 1 meter length wire. Using that, we are going to calculate the unknown resistance. Right. So that is P is the unknown resistance connected in that gap G1, and Q is the known resistance or standard resistance connected to the gap G2, and from B to galvanometer is a galvanometer to high resistance to jockey. So HR means high resistance. Then finally it is connected to the metal jockey. Metal jockey means it's made up of metal. So from A to Lagrange cell to key to point C is connected to that board. So metal jockey is moving on the metal. So using that, we can find out the galvanometer zero deflection. That means that potential current flow in the 2 side. So where that galvanometer shows zero deflection, the distance is taken as AJ and JC. So AJ is taken as L1, JC is L2. That is length L1, length L2. So P by Q equal to R by S. That is a windstone bridge law. So that is equal to R into AJ, R into JC. So V equal to IRL, you know that value, where R is the resistance per unit length of the wire. So AJ equal to L1, JC equal to length L2. So that is L1, L2. So we are writing P by Q equal to AJ by JC or L1 by L2. So P by Q equal to L1 by L2. We can write P by Q equal to L1 by L2. So R P equal to Q into L1 by L2. So if you know the value of Q and L1 and L2, you can calculate the P value. So that is the use of the meter bridge to find the unknown resistance P. You know the Q value, then L1, L2 we can calculate from that board meter bridge. So using that we can calculate the value of P. Right? So it has the end resistance. So to prevent that, we have to interchange that P and Q. Again, we can take the value to reduce the end resistance. So that is a balancing point. Again, you have to calculate the balancing point. Again, you take the remaining value. Again, you can calculate the P by Q, P equal to Q into L1 by L2. So that is a meter bridge. So next we are going to see the potentiometer. See, the potentiometer. The potentiometer has the same thing. In meter bridge, it has the only 1 meter length wire. Only 1 meter length wire. That is why it is called meter bridge. But potentiometer has the 10 segment. That is 10 meter wire is fixed on the wooden frame. And it is connected to the battery, key, and the Lachlan cell, galvanometer, and high resistance. So using that, we can calculate the current, resistance, and the potential difference by using the principle. So now we are going to see the potentiometer, right? So see that potentiometer has the principle, and using that principle, how we can calculate the current, voltage, and resistance. So this is a potentiometer, and using that it has the constant or magnet wire. It has the 10 segment. That is initially shown that is a metal scale. That scale is used for finding the length L1 and L2. That is a balancing length. Each of 1 meter length. So 10 segment lines is there. So total length is 10 meter. So this is a potentiometer. So now we are going to indicate the 2 point A and B is a single line. Okay, that single point we can take this show in the circuit. That is a scale. That using that scale we can calculate the length. So these are all the point A and B. Hereafter we are indicating only 2 points, that A and B. So now we are going to see the principle of potentiometer. So battery is key, and the AB is the potentiometer. So it is called the principal circuit. So current flow from that point A to B, that is 10 segment of wire, key, and battery. So this is called primary circuit. It's called primary circuit. Then we can take that line from that point A, then it is connected to the battery E, then galvanometer to high resistance to metal jockey. So using the metal jockey, we can find out the balancing length. So this is called secondary circuit. So it's called secondary circuit. So from A to J, that will directly proportional to the EMF of the cell. AJ is directly proportional to the EMF of the gel. So when the galvanometer shows zero deflection, that will be called the balancing length. That balancing length is taken as L. That balancing length is equal to the potential difference across the AJ equal to IRL. So IRL. So where L is the length, IR is the flow of current into resistance. So current is flow from the battery to the metal jockey through that is a primary circuit. So AJ equal to IRL, or AJ is equal to the EMF of the battery. That's why we are taking E equal to IRL. IR is a constant. That's we can write E is directly proportional to I. Hence, EMF of the cell is directly proportional to its balancing length. This is the principle of potentiometer. So EMF of the battery is directly proportional to the balancing length. So E directly proportional to AJ, or the length L. So this is the principle of the potentiometer. So now we are going to see the comparison of EMF of two cells. So using that potentiometer, we can compare the EMF of the two cells. So this is a practical one. Practical நீங்க செஞ்சு பார்ப்பீங்க. So comparison of EMF of two cells. So how we can compare the EMF of the two cells? So we can take the potentiometer. So this is a circuit diagram of the potentiometer. So here see that battery is connected to the key rheostat. Rheostat is used to increase or decrease the flow of current. and point C and D, and C is connected to that M, and N to galvanometer to high resistance to jockey. Here M1, N1, M2, N2, these are all the DP DT switch, double pole double throw switch. So DP DT switch. So DP DT switch means that is double pole double throw switch. So here we are connecting the two batteries E1 and E2. So we can compare the two batteries. So that two batteries are connected here, E1 and E2. So here that switch is one switch is on the DP DT switch. When the switch is moving in the upward direction, that E1 is connected to the circuit, primary circuit. E2 is not connected. So E1 is connected to that circuit. Suppose the switch is moving into the downward direction. E2 is connected to the primary circuit. E1 is not connected to the primary circuit. So at a time we can connect any one of the cell to the primary circuit, whether E1 or E2. So நம்ம என்ன பண்ண போறோம் அப்படின்னா டிபி டிடி சுவிட்ச்ங்கிறது டூ வே சுவிட்ச் மாதிரி. ஸோ ஏதாச்சும் ஒன்று தான் வந்து நம்ம என்ன பண்ணோம் அப்படின்னா பிரைமரி சர்க்யூட்டோட கனெக்ட் பண்ணுவோம். ஸோ வி நோ த ஃபார்முலா ஃபார் தட் பிரின்சிபல் ஆஃப் த பொட்டன்ஷியோமீட்டர். So AJ is equal to directly proportional to the balancing length. Here we have to calculate the CJ, that is the balancing length. That one for E1, and we can change the switch and we can calculate the balancing length for E2. Right? So initially the DP, by using the DP DT switch, E1 is connected to the potentiometer. First E1 மட்டும் connect பண்ணிருக்கோம். Connect பண்ணும்போது by using the jockey we can calculate the balancing length from here to here, where the galvanometer shows the zero deflection. So that balancing length is equal to the E1. So according to that law, E equal to IRL is the law of the potentiometer. So first one, E1 equal to for the balance the EMF of the battery, E1 equal to IRL1, where L1 is the balancing length. By using the jockey we are calculated the value L1. Now using the DP DT switch, that E2 is connected to the circuit, but that means switch is moving into the downward direction. Now E2 equal to IRL2. That one is the second one. So comparing the two equation E1 by E2. So when you are dividing the two value, what will happen? So here that IR cancel each other. So remaining you will get the value of E1 E2 equal to L1 by L2. So using that we can calculate we can compare the EMF of the two cells. If you know the value of L1 and L2, we can compare the value of E1 by E2. So using that formula, we can compare the EMF of the two cells. So it's one important question. So this question is asked in the public exam. இப்போ current public exam இந்த question வந்திருக்குது. அதுல வந்து பாத்தீங்க அப்படின்னா E equal to IR L1, E equal to IR L2 and E1 by E2 equal to L1 by L2. இந்த மூணு வேர்டு அதிகனாலே 3 மார்க். இந்த டயக்ராமுக்கு 1 மார்க், எக்ஸ்பிளனேஷனுக்கு 1 மார்க். ஸோ இந்த எக்ஸ்பிளனேஷன் இந்த 3 வேர்டு இருந்தாலே உங்களுக்கு 4 மார்க் கிடைச்சிடும். ஸோ அவ்வளோ ஈஸியானது ஒன்று, ரொம்ப இம்பார்ட்டன்ட், படிச்சுக்கணும்.